The rainforest rarely announces its most effective threats. Some arrive without sound, without force, without pain that demands immediate attention. Mosquitoes operate in this quiet register. You feel fine now. That is the switch. In an environment where danger is often associated with claws, fangs, or venom delivered in dramatic moments, the mosquito works on a different timeline. It does not overwhelm the body. It enters it, leaves almost nothing behind on the surface, and lets consequence accumulate elsewhere. A mosquito does not hunt randomly. Its approach is layered, algorithmic, and remarkably precise. The first signal is carbon dioxide. Every breath you exhale forms an invisible plume that drifts through the understory, heavier than air, pooling in low, still zones beneath leaves and along trail edges. Mosquitoes ride these gradients, orienting themselves upwind toward the source. As they close the distance, heat becomes the next cue. Warm skin stands out sharply against the cooler background of shaded forest, especially at dawn and dusk, when ambient temperatures drop, but human bodies remain warm. Finally comes chemistry. Skin odor shaped by sweat, bacteria, diet, and genetics. Each person broadcasts a slightly different signature, and some are simply easier to find. This layered tracking matters because it explains why avoidance often fails. People assume mosquitoes are everywhere or nowhere, a nuisance to be endured rather than a system to be managed. In reality, their presence is concentrated, predictable, and responsive to behavior. Standing still, breathing heavily after exertion, exposed skin damp with sweat, these are invitations. The mosquito does not need to see you. It needs only to follow the signals you cannot turn off. The bite itself is an exercise in subtlety. The mouthparts slide into skin with minimal force, guided by sensory hairs that locate blood vessels beneath the surface. Saliva is injected to prevent clotting and dull sensation, ensuring uninterrupted feeding. The wound is microscopic, often unnoticed until itching develops later. There is no tearing, no crushing, no immediate inflammation. The skin closes almost instantly. You feel fine now. This is why mosquitoes matter to this episode. They represent the smallest possible breach, a tiny wound that serves as a delivery method rather than an injury in itself. In a forest where bacteria, parasites, and viruses circulate constantly among animals, this breach is enough. The mosquito bridges ecosystems, moving pathogens from reservoir hosts to incidental ones without resistance or awareness. Consequence is decoupled from contact. What enters the body does not announce itself. The danger is not hypothetical, but it is delayed. Hours, days, sometimes weeks pass before symptoms emerge. Fever, joint pain, fatigue, or more severe complications appear long after the bite is forgotten. By then, the origin is abstract. People struggle to connect present illness with past exposure, especially when the exposure felt harmless. This disconnect is the mosquito's greatest advantage. It erases causality. Ecologically, mosquitoes are not anomalies. They are integral to the rainforest's nutrient cycles and food webs. Their larvae process organic matter in standing water. Adults feed birds, bats, fish, and insects. Their abundance reflects the productivity of the system itself. Warm temperatures accelerate their life cycles. Rain creates breeding sites in tree holes, leaf axils, flooded ground, and human debris alike. The forest produces mosquitoes because it produces water, heat, and life in excess. Humans amplify this unintentionally. Camps create puddles. Containers collect rain. Footprints fill with water. Trails compact soil, forming shallow basins that hold moisture longer than undisturbed ground. Even a tarp tied poorly can channel water into a perfect breeding pocket. The mosquito thrives not because humans are careless, but because we reshape hydrology at small scales everywhere we go. The responsible framing here is not fear, but prevention, and why it is ignored. Long sleeves feel oppressive in heat. Repellents smell harsh or feel greasy. Nets are inconvenient to set up at the end of a long day. Vigilance erodes with familiarity. After hours without bites, people relax. They roll sleeves. They skip reapplication. They assume risk has passed because nothing happened yet. The mosquito exploits fatigue and comfort, not ignorance. There is also a psychological mismatch. Humans respond to immediate feedback. We adjust behavior when pain follows action closely. The mosquito offers no such lesson. The bite is forgettable. The itch fades. The body feels normal. Without reinforcement, protective habits decay. People reserve caution for visible threats and dramatic encounters, not for something that barely registers as an event. This ties directly back to the broader theme of delayed consequence. Throughout the rainforest, the most dangerous interactions are often those that do not incapacitate immediately. Rot does not begin with collapse. Infection does not announce itself at the moment of entry. The mosquito is the purest expression of this logic. It is the most common attack precisely because it looks like nothing at all. From a physiological perspective, this delay complicates response. The immune system reacts only once a pathogen begins replicating or triggering inflammation. By then, the mosquito is long gone. There is no wound to clean, no venom to neutralize, no immediate intervention to perform. Prevention is the only meaningful defense, and it must be applied before the threat feels real. That is a difficult demand for a nervous system evolved to respond to urgency, not anticipation. Even the body's reaction to bites reinforces complacency. Itching is localized, superficial, and familiar. It suggests irritation, not invasion. Scratching satisfies the sensation temporarily, further trivializing the event. Unlike venomous encounters that dominate attention, mosquito bites fade into the background of experience, remembered only as annoyance. Meanwhile, the biological clock may already be running. The rainforest's lesson here is uncomfortable. Not all danger is proportional to sensation. Not all threats escalate visibly. Some arrive quietly, embed themselves, and wait. The mosquito does not need strength, speed, or aggression. It needs access and time. Its success is measured not in dramatic outcomes, but in ubiquity. At a systems level, mosquitoes shape human behavior in the rainforest more than most predators. They influence where people sleep, when they move, how they dress, and which areas they avoid. Entire patterns of settlement and travel have evolved in response to their presence. This is not because mosquitoes are feared, but because their delayed impact is respected by those who understand it. The final punch is not meant to alarm. It is meant to recalibrate attention. In the rainforest, harm is not always immediate. The environment does not always hit hard. Sometimes it hits later, after you have moved on, after vigilance has dropped, after cause and effect have separated in memory. The quiet switch is believing that feeling fine now means being safe. The first thing people misunderstand about a caiman bite is that survival feels like the end of the story. The jaws open, the animal releases, the body is still intact, and the mind registers a simple, dangerous relief. I'm alive. In the Amazon, that feeling is often premature. The river has a long memory, and the damage done by a caiman rarely announces itself in the moment of impact. It hides in crushed muscle, starved blood vessels, and invisible pockets of dying tissue that continue to unravel long after the animal disappears beneath the surface. Caimans do not bite like knives. Their teeth are not designed to slice cleanly or shear tissue the way a predator optimized for flesh-tearing would. Instead, the jaws close with a force that compresses, shatters, and deforms whatever lies between them. Muscle is flattened, connective tissue is pulped, and blood vessels collapse under pressure rather than being neatly severed. This is the critical distinction. A clean cut bleeds, drains, and signals damage clearly. A crushing bite seals its own injury, destroying circulation at the margins while leaving the skin deceptively intact. When a caiman adds its characteristic twist, rolling or shifting its head to destabilize prey, the effect multiplies. Tissues are not just crushed, they are torqued, torn from their anchoring planes and left metabolically stranded. From the outside, the wound may look survivable. Teeth marks, bruising, swelling, perhaps a torn patch of skin. Inside, blood supply has already failed in ways that cannot be seen. Capillaries rupture or clamp shut, muscle fibers lose oxygen, and cells begin dying not because they were torn apart, but because they were quietly suffocated. This is where the injury switches from trauma to something far more dangerous. Dead tissue is not inert. It is food. Amazonian waterways are rich in microbial life adapted to warmth, organic matter, and fluctuating oxygen levels. Bacteria here are not rare contaminants. They are foundational players in nutrient cycling, decomposition, and sediment chemistry. When dead tissue pockets form beneath intact skin or partially closed wounds, they create ideal growth chambers, warm, moist, low in oxygen, and shielded from immune surveillance. River water does not need to flood the wound to cause infection. It only needs to seed it once. The body's own inflammatory response then does the rest, swelling tissue and sealing bacteria inside. As inflammation spreads, the edges of the wound begin to fail. Cells already weakened by reduced blood flow cannot tolerate the additional pressure of swelling. They die in expanding rings, enlarging the injury without any new external force. This is why caiman wounds appear to grow over time. What began as a localized bite becomes a widening zone of tissue loss, discoloration, and breakdown. Pain increases, mobility decreases, and each movement pumps bacteria-laden fluids through damaged planes of muscle and fascia. The river may be meters away now, but its biology is already at work inside the body. The irony is that many caiman encounters occur during moments of perceived control. A person slips while stepping onto a muddy bank, grabs reeds to steady themselves, or leans too far while managing a fishing line tangled near the water's edge. The caiman reacts to vibration, pressure waves, or sudden splashes, not as a calculated attack, but as a territorial or defensive response. The bite is brief, often followed by release as the animal reassesses. In those seconds, the human mind shifts from panic to problem-solving, focused on extraction, bleeding, and escape. The deeper damage is still silent. Caimans themselves are products of this same river logic. As ectotherms, their metabolism, digestion, and activity patterns are governed by temperature. Warm water accelerates their reflexes and muscle performance, while also favoring the microbial communities that decompose prey remains. When a caiman kills, it often does not consume immediately. Instead, it may store prey underwater, allowing bacteria to soften tissue before feeding. This ecological partnership between predator and microbes is efficient in the wild, and devastating when replicated unintentionally in human wounds. The same bacteria that help break down a drowned capybara or fish carcass are exquisitely capable of exploiting crushed human tissue left without oxygen. As hours pass, the human body enters a losing negotiation. The immune system floods the area with white blood cells, increasing heat, swelling, and pain. Fever may begin as the body signals that it is fighting an internal invasion. But without adequate blood flow, immune cells struggle to penetrate the very tissue they are meant to defend. Antibiotics, if delayed, face the same obstacle. They travel through blood, not through dead zones. What looks like aggressive treatment can fail simply because the medicine cannot reach its target. Mobility declines in predictable ways. A leg wound alters gait, forcing weight onto joints and muscles not designed for prolonged compensation. A hand injury reduces grip strength and dexterity, turning routine tasks, climbing a bank, securing a boat, filtering water, into risks. Fatigue sets in faster as the body diverts energy toward inflammation and healing. In the Amazon, exhaustion is not just uncomfortable, it is dangerous. Heat, humidity, insects, and unstable terrain amplify every weakness. Each stumble, each misjudged step near the river's edge creates new opportunities for harm. The psychological trap is subtle. Surviving the bite creates a narrative of victory. The caiman is gone. The immediate threat has passed. People begin to downplay symptoms, attributing worsening pain to bruising or strain rather than infection. Delays accumulate, waiting until morning, until reaching a village, until the pain becomes unbearable. By then, tissue loss may be extensive and systemic infection a real risk. The river's punishment is not swift. It is patient. Ecologically, caimans function as regulators of river margins, shaping prey behavior and influencing where animals drink, cross, or graze. Their presence keeps herbivores moving and prevents overuse of vulnerable banks. In this way, they maintain the health of the ecosystem that sustains them. Human encounters are not part of this system's design, but they are shaped by it. When people enter these environments, they step into a network of interactions already tuned to punish hesitation and reward vigilance. The aftermath of a caiman bite reveals a deeper truth about survival in the Amazon. Danger is not confined to the moment of contact. It unfolds through time, biology, and environment, exploiting any lapse in attention or care. The river does not need to chase you. It only needs you to believe the worst is over. Long after the splash fades and the surface smooths, the consequences continue to spread cell by cell, reminding survivors that in this ecosystem, victory is never declared at the bite. It is negotiated afterward against microbes, metabolism, and the slow, relentless logic of the river itself. The forest does not need to move to hurt you. Some of its most effective defenses are stationary, silent, and small enough to vanish into pattern. Venomous caterpillars do not chase, strike, or threaten. They exist as texture, extensions of bark, leaves, and moss, occupying the same visual bandwidth as the surfaces people lean on, brush past, or wipe sweat against without looking. In the Amazon and other tropical forests, danger often begins not with aggression, but with contact so ordinary it barely registers as an event. Caterpillars evolved this way because they are edible. Slow, soft-bodied and rich in nutrients, they sit low on the food chain, exposed to birds, mammals, reptiles and insects that specialize in stripping foliage clean. Flight is impossible. Speed is irrelevant. Their survival depends on discouraging the first bite. Venomous spines solve that problem elegantly. Instead of delivering poison through a single puncture, these caterpillars distribute it across hundreds or thousands of microscopic structures, turning their entire surface into a weaponized field. The mechanism is simple and devastating. Urticating spines, often hollow, brittle and barbed, stand erect along the caterpillar's body. On contact, they penetrate skin like glass fibers. They do not slide out cleanly. They snap. Each break leaves a fragment embedded in tissue, carrying venom proteins and irritants designed to trigger intense local inflammation. There is no central wound to clean, no obvious entry point. The injury is diffuse, fragmented, and difficult to see with the naked eye. This is where contact becomes contamination. The initial sensation is often delayed by seconds, sometimes minutes. A brush against foliage, a hand resting on a trunk, a forearm sliding through leaves while clearing a trail or reaching for fruit. Then the burning begins, sharp, spreading and persistent. It does not behave like a sting or a bite. It feels as if the skin itself has been compromised, as if heat is being generated from within rather than applied from outside. Itching follows quickly, intense and insistent, demanding attention in a way few other sensations do. The switch happens almost automatically. Humans are wired to rub pain away. Scratching is instinctive, a reflex meant to dislodge irritants and stimulate competing sensory signals that dampen discomfort. In this case, it is the worst possible response. Every rub breaks more spines, drives fragments deeper, and spreads them across a wider area of skin. Venom disperses. Inflammation expands. What might have remained a localized reaction becomes a broad, persistent injury, maintained not by the caterpillar, but by the victim's own movements. The forest provides endless opportunities for this mistake. Trail clearing brings arms and faces into contact with hanging branches. Harvesting fruit requires reaching blindly into clusters of leaves where caterpillars feed and rest. Sweat runs constantly in humid heat, and wiping it from the face or neck smears invisible spines across sensitive skin. Even brushing clothing clean transfers fragments from fabric to hands, and then to new areas of the body. The injury propagates through routine behavior, not escalation. From a biological perspective, this strategy is extraordinarily efficient. The caterpillar does not need to deliver a precise dose or target a vital area. It only needs to ensure that contact is unpleasant enough to prevent predation. Birds learn quickly. Mammals recoil after a single encounter. The venom is not optimized to kill, it is optimized to teach. Humans, however, do not receive the lesson cleanly because they do not recognize the source immediately. The caterpillar remains unnoticed while the reaction unfolds elsewhere. Inflammation becomes the dominant process. Blood vessels dilate, bringing immune cells to the area. Swelling increases, stretching skin and amplifying pain signals. The embedded spines act as foreign bodies, continuing to irritate tissue as long as they remain. In some species, the venom's effects go beyond the skin, triggering systemic symptoms, headache, nausea, joint pain, not because the caterpillar is aggressive, but because the immune response has been pushed too far, too fast. There is also a psychological trap embedded in this injury. Itching creates urgency without clarity. Unlike sharp pain, which signals a specific location and cause, itching feels diffuse and unresolved. The mind searches for relief, cycling through scratching, rubbing, washing, each action worsening the condition. Frustration builds. Sleep becomes difficult as sensations flare whenever attention drops. The injury occupies mental space disproportionate to its size, eroding focus and patience. Ecologically, venomous caterpillars are signals woven into the forest's fabric. Many are brightly colored, advertising toxicity to predators that see them clearly. Others rely on camouflage so complete that warning comes only after contact. Both strategies work because the cost of a mistake is immediate and memorable. Predators that ignore the signal do not repeat the behavior. The forest remains balanced through countless small deterrents rather than a few dramatic threats. Humans struggle because they move differently. We do not peck, nip, or sample cautiously. We push through. We lean. We wipe. We clear. Our skin becomes the interface between ourselves and the environment, and venomous caterpillars exploit that interface without intent or awareness. The injury is not personal. It is mechanical. Time changes the injury's character. Hours after exposure, swelling may peak. Redness spreads beyond the original contact zone. The skin feels hot, tight, and hypersensitive. In severe cases, blisters or necrotic patches can develop where venom concentration was highest. Secondary infection becomes a risk when scratching breaks the skin barrier repeatedly. What began as microscopic fragments becomes a macroscopic problem. Management depends on understanding the mechanism. Removing spines requires patience, tape to lift fragments, careful washing, avoidance of friction. Anti-inflammatory measures help, but only after the physical irritant is addressed. Delay prolongs suffering because the source of irritation remains active. The forest does not escalate. It simply waits while biology plays out. There is an irony here that mirrors many tropical hazards. The most damaging encounters often involve the smallest animals. No fangs, no speed, no pursuit, just a surface that punishes touch. Venomous caterpillars remind us that not all defenses are directional. Some are distributed, passive and persistent, turning the environment itself into a deterrent. The close punch is not about fear of insects. It is about misjudging scale. People look for danger in size, movement, and aggression. The forest operates on a different logic. It defends itself through chemistry, texture, and time. Contact becomes contamination. The reaction grows not because the caterpillar attacks again, but because the human body and mind do exactly what they evolved to do: rub, spread, inflame. In the end, venomous caterpillars embody a quiet rule of tropical ecosystems. You do not need teeth to leave a mark. The forest doesn't need fangs. The centipede does not announce itself as a threat because it does not need to. It occupies the same layer of the forest that humans treat as inert: dead wood, loose bark, overturned stones, piles of damp debris at the edges of camps and trails. These are not hiding places in the dramatic sense. They are functional refuges, cool, humid, dark, and crowded with invertebrate life. To the centipede, they are highways and larders. To a human hand, they are leverage points, things to grip, lift, clear, or rearrange without thought. Scolopendra lives where contact is intimate. It does not wait in open view or patrol obvious routes. It compresses itself into cracks and folds, flattening its long, segmented body to fit spaces that feel solid until they move. Under bark peeled slightly away from a log, beneath stones that trap moisture overnight, inside rotting wood hauled closer to a fire, in the seams of packs, tarps, and boots left on the ground. Camps create ideal microhabitats without meaning to: warmth, shelter, prey, and long periods of stillness. Encounters happen not because the centipede seeks people, but because people put their fingers exactly where it rests. When disturbed, the centipede reacts with speed and violence that feels disproportionate to its size. This is not aggression. It is a last resort defense from an animal that knows it cannot outrun a crushing force. The first movement is the forcipules, modified front legs curved like hooks beneath the head. They strike downward and inward, puncturing skin and delivering venom directly into tissue. Unlike a single controlled sting, the centipede's response is chaotic. Its body thrashes, segments flexing independently, each movement increasing the chance of additional punctures along the same hand or finger. What feels like one bite is often several injections delivered in rapid succession. The venom does not spread explosively. It burns deep. Pain radiates outward from the puncture sites, not sharp and fleeting, but heavy and consuming, as if heat has been poured into the limb and cannot drain away. The sensation intensifies as swelling begins, compressing nerves and blood vessels in tight spaces like fingers and hands. This is the core of the danger. Hands are tools. They are required for balance, climbing, cutting, carrying, and self-care. When they fail, the entire body becomes less capable. This is the switch. Loss of function. Swelling transforms fine movement into blunt force. Fingers stiffen, joints lock, and grip strength collapses. Even holding a bottle, tying a knot, or opening a pack becomes difficult. Pain demands attention constantly, pulling focus inward and away from terrain, footing, and situational awareness. People make decisions under this pressure, rushing tasks, favoring injured limbs poorly, improvising with reduced dexterity. Mistakes multiply quietly. The centipede does not need to escalate. The handicap is already in place. In the humid jungle, recovery is slower and irritation persists longer. Skin remains moist, softening tissue and prolonging inflammation. Sweat seeps into puncture sites, carrying salt and bacteria that aggravate already stressed nerves. Bandages loosen or stay wet. Airflow is limited. The body struggles to cool effectively as pain elevates stress hormones and heart rate. What would be a painful but contained injury in a dry environment becomes a lingering problem, refusing to settle. From an ecological standpoint, this venom is perfectly tuned. Centipedes hunt prey that fights back: cockroaches, beetles, spiders, even small vertebrates. Immobilization matters more than lethality. Venom that causes intense pain and swelling quickly incapacitates struggling prey, preventing escape or injury to the centipede's many vulnerable segments. Humans experience the same effect at a different scale. The venom does not threaten life directly. It threatens capacity. The forest amplifies this loss. Tasks that rely on hands are unavoidable. Clearing brush, setting shelter, cooking, treating wounds, maintaining footing on uneven ground, each requires precision. When that precision is gone, exposure increases. Scrapes become more likely. Falls more frequent. Small injuries accumulate. The original puncture fades into the background as secondary problems take over. There is also a psychological trap. Centipedes look primitive, almost mechanical. People underestimate them instinctively, assuming that something so ancient and segmented must be limited in effect. The reality is the opposite. Their design has been refined for hundreds of millions of years to function in exactly these conditions. Moisture does not weaken them. Darkness does not hide them from prey. Confined spaces do not trap them. Everything about their biology favors close-range encounters where thrashing defense is most effective. Human scenarios repeat predictably. A log is rolled to make a seat. A rock is lifted to clear a tent site. Firewood is grabbed bare-handed. Boots left outside are slipped on without inspection. In each case, the centipede is not attacking from concealment. It is reacting to compression, pressure, and sudden exposure. The injury is instantaneous. The consequences are not. As hours pass, swelling may increase before it recedes. The limb feels heavy, unresponsive, foreign. Pain pulses with heartbeat and movement. Sleep is interrupted as any shift reactivates sensation. Fatigue sets in, compounding the original loss of function. Infections are not inevitable, but the risk is present whenever skin integrity is compromised in a warm, wet environment. Even without infection, inflammation alone can keep a hand or foot partially unusable for days. What makes Scolopendra dangerous is not venom potency measured in isolation. It is context. In the jungle, partial disability is enough. A person with one compromised hand is slower, less stable, less capable of adapting when something else goes wrong. The centipede's role in the ecosystem is not to kill large animals. It is to make contact costly. That cost scales upward with environment. There is a final irony here. The centipede is itself vulnerable, soft-bodied, elongated, easily crushed. Its defense is to ensure that anyone who touches it pays immediately and persistently. The pain teaches avoidance. The swelling enforces it. Predators learn quickly. Humans often learn late. The close punch is not about fear of arthropods. It is about understanding leverage. In complex terrain, survival depends on function more than strength. A small predator that takes your hands away for a day has taken far more than skin. Small predator, big handicap. The river looks calm when piranhas are present. That is the first misread. There is no surface signal, no circling fins or boiling water to announce danger. The Amazon does not advertise its transitions. Piranhas exist as a background condition, distributed through flooded forests, oxbow lakes, slow channels, and backwaters where heat lingers and organic matter accumulates. They are not hunters of spectacle. They are surgeons of opportunity. And they do not need to consume a body to change its fate. They only need to open it. A piranha bite is over almost before it registers. The jaw closes with a snap driven by some of the fastest jaw-closing musculature relative to body size in freshwater fish. The teeth meet edge to edge like shears, not points or hooks. Each triangular tooth is sharpened along a cutting face, designed to remove a precise wedge of tissue in a single motion. There is no tearing, no grinding. Flesh is sliced cleanly and released immediately. This matters more than people realize. Clean cuts bleed efficiently. Blood vessels are severed without being crushed shut, and the body has no time to constrict or clot before blood escapes into warm water. The injury itself is deceptively small. A missing crescent of skin, a neat scooped divot from a fingertip or toe. Pain is immediate but not overwhelming, sharp rather than crushing, and this creates a false hierarchy of threat. People associate danger with intensity, burning venom, shattered bone, overwhelming force. A piranha delivers none of these. What it delivers is exposure. Tissue that was meant to be sealed is suddenly open, and in the Amazon, open tissue is an invitation. The switch happens fast and quietly. Warm water accelerates everything. Blood loss, bacterial metabolism, inflammatory response. Stress compounds it. Heart rate rises, blood pressure increases, and bleeding intensifies. Panic leads to poor decisions. Hands plunged back into the water, improvised bandaging with contaminated fabric, delayed cleaning because the wound looks manageable. The body's first response is to swell and inflame, which narrows the wound opening and traps whatever entered in those first seconds. River water does not need to be filthy to be dangerous. It is alive, dense with microorganisms adapted to heat, decay, and low oxygen environments. Once sealed inside tissue, they do not need volume. They need time. This is where the popular myth collapses. Piranhas are not frenzy machines waiting to strip skeletons. They are opportunists responding to disturbance, vibration, and chemical cues. A struggling fish, a bleeding animal, or a sudden burst of activity draws attention, but not in coordinated swarms. Individuals converge, test, retreat, and return. One bite does not trigger a feeding cascade unless conditions are already extreme: drought, overcrowding, or active baiting. Most human injuries occur not during swimming, but during handling. Unhooking fish, managing nets, carrying bait, or wading with unnoticed cuts already present. Fingers bleed. Water clouds. A fish reacts reflexively, not maliciously. The damage is done in a fraction of a second. Ecologically, this behavior makes perfect sense. Piranhas evolved in systems where energy efficiency matters. Flooded forests expand the river's footprint seasonally, dispersing food over vast areas. Chasing prey would be wasteful. Instead, piranhas patrol and wait, conserving energy until a signal suggests vulnerability. Their teeth are tools for rapid sampling, not prolonged combat. A quick cut tests whether prey can escape. If it cannot, further bites follow. If it can, the piranha withdraws and looks elsewhere. This strategy has worked for millions of years, shaping fish populations and recycling injured or dying animals back into the system. For humans, the danger is rarely the bite itself. It is what follows. Open wounds bleed longer in warm environments, and prolonged bleeding is not just a loss of blood, it is a loss of control. Hands become slippery. Grip weakens. Fine movements degrade. Tasks that require precision near water become risky. Climbing a muddy bank, steadying a canoe, or managing equipment while injured increases the chance of falls, immersion, or secondary injuries. Each new scrape or cut compounds the problem, expanding the surface area exposed to contamination. The biology of wound healing works against you here. In temperate environments, cooler temperatures slow bacterial growth and reduce inflammation. In the Amazon, heat accelerates both. Swelling increases rapidly, closing wounds prematurely before thorough cleaning can occur. Stress hormones suppress certain immune functions even as inflammation rises, creating a mismatch between response and effectiveness. If the cut is on a finger or toe, circulation is already limited compared to larger muscle groups, making it easier for infection to take hold. What began as a minor injury can evolve into cellulitis, abscess formation, or systemic infection if neglected. There is also the problem of underestimation. Because piranha injuries are often small and sharply defined, people delay care. The pain subsides. Bleeding slows. Movement feels possible again. This is the most dangerous phase. Bacteria multiply invisibly, and tissue edges begin to fail from the inside. Redness spreads. Heat builds. Pain returns, deeper and more diffuse than before. By the time intervention feels urgent, the wound has already changed character. Piranhas themselves remain indifferent to this aftermath. They do not pursue. They do not remember. The river absorbs the blood, disperses the chemical signal, and resets. From an ecological perspective, nothing unusual has occurred. An animal tested a vulnerability. Energy was conserved. The system moved on. Humans struggle because they expect intent where there is only function. There is a quiet cruelty in this interaction. The injury feels trivial compared to the stories people tell about the Amazon. No dramatic struggle, no visible predator, just a sudden absence of tissue and the slow realization that something fundamental has been compromised. The river does not punish through spectacle. It punishes through process. Understanding this changes how risk should be read. Danger is not proportional to size or aggression. It is proportional to exposure. Piranhas exploit moments when boundaries fail, when skin opens, when blood enters water, when attention drifts during routine tasks. They do not need to eat you. They do not need to surround you. They only need a brief opening, measured in seconds, to set a much longer sequence in motion. In the Amazon, survival is rarely decided at the moment of contact. It is decided in the minutes and hours that follow, when physiology, environment, and behavior intersect. A piranha cut is a reminder that harm does not always arrive as an overwhelming force. Sometimes it arrives as a precise subtraction, clean and efficient, leaving the rest to biology and time. The cut is brief. The risk is everything that comes after. The first warning is not visual. It is structural. In the lowland rainforest, the surfaces you trust most, tree bark, vines, exposed roots, are not neutral supports. They are traffic lanes. Bullet ants do not wander aimlessly. They move along established routes that connect nest to canopy, soil to sap, trunk to liana. These trails are invisible unless you know how to read them, etched not into the ground, but into behavior. A hand closes around bark to steady a step. A foot lands near a root that looks solid enough. A vine is pulled aside to clear a path. Contact is brief, accidental, and decisive. Bullet ants are not aggressive by default. They are territorial, methodical, and acutely aware of vibration. Their nests are defended not by size or numbers alone, but by certainty. When a trail is disturbed, the response is immediate and localized. Workers converge, not to chase, but to neutralize the source of disruption. The sting is not a last resort. It is the primary tool delivered with precision and intent. The ant does not need to hold on. It needs to inject and disengage, leaving the venom to finish the interaction. Pain is not a side effect of this venom. It is the point. The chemistry of a bullet ant sting is engineered to hijack the nervous system's attention. The venom activates pain pathways so intensely that they override competing signals. Muscles tense involuntarily. Limbs shake. Nausea rises not from gastrointestinal injury, but from neurological overload. Sweating increases as the body attempts to dissipate stress it cannot escape. Thermoregulation falters because pain demands priority over balance, hydration, and coordination. The sting does not damage tissue significantly. It damages control. This is the evolutionary insight. Killing is unnecessary. A predator that drops its prey, a mammal that recoils and flees, a bird that abandons a perch. All outcomes favor the ant colony without the metabolic cost of lethal toxins. Pain creates distance. Pain creates memory. Pain reshapes behavior. In the Amazon, where encounters repeat along the same routes day after day, that matters more than mortality. For humans, the effect is immediate and disorienting. The sensation is not localized like a cut or a burn. It radiates, pulsing and expanding, filling awareness until everything else recedes. Fine motor control collapses. Hands open when they should grip. Knees weaken. Balance becomes unreliable as muscles fire unpredictably. The body is still strong enough to move, but no longer precise enough to move safely. This is the critical transition point. The switch happens when stings stack. One sting is debilitating. 2 or 3 overwhelm the nervous system's ability to compartmentalize pain. Each new injection resets the intensity, extending the duration and deepening the physiological disruption. People flail, swat, stumble, natural reactions that bring more skin into contact with more ants. The colony does not need to pursue. The victim's own movements create the exposure. This is where the jungle enters the equation. Loss of control leads to falls. Falls lead to scrapes against bark, stone, and thorn. Skin opens. Dirt embeds. Sweat carries bacteria into fresh wounds. The original problem, pain, has now cascaded into injury. The ants did not wound you. They made you clumsy enough to do it yourself. Ecologically, this makes bullet ants remarkably effective defenders. Their nests are often located at the bases of trees or along frequently used animal paths, where large mammals are most likely to brush past. A jaguar, tapir, or primate does not need to be injured to learn avoidance. One encounter is enough to reroute behavior. Over time, this shapes movement patterns through the forest, subtly influencing which paths are favored and which are abandoned. The ants do not dominate through numbers alone. They dominate through consequence. Human scenarios mirror this perfectly. A slip on a muddy incline prompts a grab at the nearest vine. A misjudged step over a log sends a hand down for balance. Trail shortcuts funnel movement into narrower corridors where ant traffic is densest. Low attention compounds risk. Fatigue narrows focus. People look ahead, not down or to the sides. The forest does not punish ignorance immediately. It waits for contact. Once stung, decision-making degrades. People rush when they should slow. They attempt to run through pain, increasing heart rate and venom distribution. Dehydration accelerates as sweating continues unchecked. Overheating becomes a real threat, not because the environment changed, but because the body's internal signals are scrambled. Panic adds another layer. amplifying the perception of threat and further disrupting coordination. The ant does not need to sting again. The damage is already propagating. This is where the danger becomes indirect and therefore underestimated. Bullet ant venom is not known for killing humans outright. This leads to dismissal, to the idea that the experience is survivable and therefore manageable. What this framing misses is the secondary risk. Open wounds in the jungle are liabilities. Reduced mobility invites further accidents. Exhaustion limits response options. A person who cannot control their body reliably is vulnerable in terrain that demands constant negotiation. From a systems perspective, the ant's venom functions as a behavioral override. It temporarily rewrites priorities, forcing the victim to focus inward at the expense of environmental awareness. In doing so, it creates opportunities for the environment to do the rest. Slippery ground, sharp debris, insects, heat, and microbial life are always present. The venom simply lowers the threshold at which they become dangerous. There is a cultural temptation to frame this pain as a test of endurance, something to be borne or even celebrated. This misses the biological intent entirely. Endurance is irrelevant. Control is what matters. The longer the pain dominates, the longer coordination remains compromised. The risk window stays open not because the ant is powerful, but because the human body is distracted. Bullet ants themselves are indifferent to the outcome. Once the disturbance retreats, the colony resumes its routines. Trails are repaired. Traffic flows again. The ecosystem absorbs the event without disruption. The human, however, must manage the consequences in a setting that offers little forgiveness for error. The close punch is not about toughness. It is about agency. The venom does not kill you. It controls you. It strips away the fine margins of competence that keep people safe in complex terrain. In the jungle, that loss of control is often enough. The Black Widow does not announce itself through movement or aggression. It occupies the forgotten spaces, those compressed margins where human attention thins out and routine takes over. Corners behind stacked chairs, the undersides of seats, wood piles leaned against walls, storage bins that are opened once a season and then sealed again. These places are not random. They share the same environmental signature: low disturbance, stable humidity, and a reliable trickle of insects drawn to shelter and debris. The widow does not chase prey or wander in search of novelty. It waits, conserving energy, letting the ecosystem deliver food to its doorstep. From an ecological perspective, this strategy is brutally efficient. The Black Widow's web is not designed for elegance or visibility. It is irregular, three-dimensional, and anchored low, meant to intercept crawling insects rather than flying ones. Beetles, ants, small orthopterans, organisms that move through clutter rather than open air, are its primary currency. By choosing human-adjacent micro-habitats, the spider benefits from the waste streams of our lives: scraps, warmth, artificial light that draws insects, and structures that remain unchanged for months. The widow does not invade homes so much as exploit the environmental stability humans create. Encounters happen when that stability is broken. A hand slides under a seat. Firewood is lifted without inspection. A storage box is dragged forward, its underside scraped across concrete. The spider does not perceive a human as prey, but as an overwhelming disturbance to a carefully tuned trap. Its response is not pursuit, but defense, fast, localized, and measured. The bite itself is often barely felt. A pinprick. A small sting that registers as nothing more than a scratch or splinter. There is no dramatic puncture, no tearing of tissue, no immediate signal that something serious has occurred. This is where the danger begins. Black widow venom is not optimized for killing large animals. It is optimized for hijacking neuromuscular communication. The toxins target synapses, forcing nerve endings to dump neurotransmitters uncontrollably. Muscles contract when they should not. Signals fire without coordination. The body's finely balanced system of tension and release collapses into a state of continuous activation. At first, this is subtle. A tightening near the bite, a strange discomfort that feels more like muscle fatigue than injury. People dismiss it instinctively. They keep working, keep lifting, keep moving, unaware that the switch has already been thrown. As minutes stretch into hours, the effect spreads. Cramping migrates outward from the bite site, wrapping around joints and into large muscle groups. The abdomen tightens, not sharply, but persistently, as if braced against an unseen blow that never arrives. The back stiffens. The chest begins to feel constricted, not because air cannot enter the lungs, but because the muscles involved in breathing refuse to relax. This distinction matters. The sensation mimics anxiety and panic so closely that many people misinterpret the cause, assuming stress or dehydration rather than envenomation. The body's response compounds the problem. Continuous muscle contraction generates heat, raising core temperature without the relief of movement or exertion. Sweating increases, drawing water out of the bloodstream. Electrolytes drift out of balance as muscles fire repeatedly without rest. Sleep becomes impossible. Every attempt to relax triggers another wave of tension, another spasm, another reminder that control has been lost. The misery is not explosive. It is total. This is why people lose to black widow bites, not because the venom is unstoppable, but because it is underestimated. The early phase feels manageable, ignorable. There is no dramatic collapse, no immediate crisis to demand attention. People delay care, believing they can push through, that the discomfort will fade. In hot environments, dehydration accelerates the venom's effects by reducing blood volume and impairing thermoregulation. Continued physical work increases metabolic demand, amplifying muscle pain and cramping. By the time the full picture becomes undeniable, the body is already exhausted. From a survival perspective, the venom's design is elegant. The widow rarely needs to kill outright. Incapacitating prey is enough. A beetle tangled in silk does not need to die quickly. It only needs to stop resisting. Humans experience the same logic, scaled up. The venom does not threaten life directly in most cases. Instead, it threatens function. You can't rest. You can't regulate your body. You can't escape the sensation of being locked into your own muscles. There is a cultural failure in how these bites are discussed. Popular narratives fixate on death, on fatality rates and dramatic outcomes, obscuring the real hazard. The danger is not that you will die in the next hour. The danger is that the night will become unmanageable, that your body will refuse to downshift, that breathing will feel wrong even when it is adequate, that pain will migrate unpredictably, robbing you of focus and rest. This is not cinematic terror. It is prolonged suffering. Ecologically, the black widow occupies a narrow but important role. By targeting crawling insects in low, stable environments, it suppresses populations that would otherwise flourish in human-altered landscapes. It thrives precisely because it does not need pristine wilderness. It needs neglect. Every untouched corner becomes potential habitat. In this way, the spider mirrors a broader pattern. Organisms that exploit human order rather than chaos often pose the most unexpected risks. The bite's delayed escalation teaches a lesson about time and attention. Immediate threats are easy to respect. Delayed ones require discipline. Recognizing that a tiny wound can trigger systemic effects demands an understanding of physiology rather than instinct. It requires people to act before discomfort becomes unbearable, to hydrate, rest, seek care, and interrupt the cascade early. The widow punishes those who wait for permission from pain. By nightfall, the scale of the event becomes clear. The bite itself is already forgotten, a non-event in memory. What dominates is the body-wide takeover, the inability to settle, the relentless contraction, the sense that relief is always just out of reach. This is not a night topic in the sense of horror stories told around a fire. It is a biological delay, a slow build that transforms a trivial encounter into an all-consuming experience. The Black Widow does not chase. It does not threaten. It sits quietly in the spaces people stop seeing, relying on patience rather than power. The bite is tiny. The night becomes huge. Night reorganizes the forest floor, and with it the rules of encounter. Heat lingers after sunset, trapped under leaves and inside wood piles, boots, baskets, and the dark folds of human habit. This is when the Brazilian wandering spider becomes most itself, not lurking, not waiting in a web, but moving. It does not build silk traps or retire to a fixed address. It hunts on foot, ranging across leaf litter, plantation rows, and the accidental shelters humans create without noticing. In this overlap, the bite is rarely the result of intrusion into wild space. It is the result of wearing the wrong place at the wrong time. The wandering spider's reputation is built on venom, but its real advantage is mobility. While many spiders commit to a single web or burrow, this one patrols, guided by vibration, scent, and the simple logic of prey density. Agricultural landscapes suit it perfectly. Banana plants, stacked lumber, stored boots, folded clothes on a concrete floor, all mimic the shaded, humid refuges it would use in the forest. These spaces trap heat and moisture, slow airflow, and concentrate insects. To the spider, they are not human objects. They are micro-habitats. Encounters happen because the spider chooses cover, not conflict. A boot left overnight becomes a cave. A pile of clothes on the floor becomes leaf litter. A banana bunch is not cargo, it is shelter wrapped around food. When disturbed, the spider does not flee blindly. It assesses distance and threat with speed that feels disproportionate to its size. If escape is blocked, by fabric tightening around its legs, by pressure from a foot or hand, it switches instantly from movement to defense. There is no warning web to tear through, no prolonged standoff. The strike is a reflex shaped by predation pressure from birds, mammals, and reptiles that kill quickly and from above. The bite itself is mechanically straightforward and biologically efficient. Large fangs, proportionally massive for a spider, arc downward with enough force to penetrate skin through fabric. Venom delivery is rapid, driven by muscles evolved to immobilize struggling prey before it can retaliate. This is not a spider that relies on prolonged chewing or repeated bites. One clean injection is enough. The fangs withdraw immediately, and the spider attempts to escape, its role in the encounter already complete. What follows is where the real danger lives. The venom does not simply cause pain. It interferes with the nervous system, triggering a cascade of effects that ripple outward from the bite site. Pain surges first, intense, burning, and disproportionate to the wound's size. Sweat follows, not as a response to heat, but as a neurological signal misfiring through autonomic pathways. Muscles begin to tremble, not from weakness, but from overstimulation. Nausea rises as the body struggles to reconcile conflicting signals about temperature, hydration, and stress. These are not separate symptoms. They are a system slipping out of alignment. This is the switch. The bite is over in a fraction of a second, but the body's reaction accelerates for minutes to hours afterward. Anxiety amplifies everything. Heart rate climbs. Breathing quickens. Hyperventilation reduces carbon dioxide levels in the blood, tightening blood vessels and worsening dizziness and tingling. Sweating increases fluid loss, pushing the body toward dehydration in an already hot environment. Thermoregulation begins to fail, not because the ambient temperature is extreme, but because the nervous system can no longer coordinate heat dissipation efficiently. The victim feels as if they are overheating from the inside out. From an evolutionary perspective, this venom profile makes sense. The spider hunts animals that rely on speed and coordination: cockroaches, grasshoppers, small vertebrates. Disrupting neuromuscular control incapacitates prey quickly and reduces the risk of counterattack. Humans experience the same disruption, scaled up by body size and psychology. The venom is not designed to kill us. It is designed to overwhelm control systems. Panic does the rest. Risk escalates with distance. In areas close to medical care, most bites are survivable with prompt treatment. Anti-venom, monitoring, and supportive care interrupt the cascade before it becomes dangerous. In remote settings, delay compounds every effect. Sweating and vomiting reduce circulating volume. Tremors increase energy expenditure. Fear keeps the body in a prolonged stress response, suppressing digestion and immune function while exhausting reserves. What was manageable becomes ugly, not because the venom changes, but because the environment removes the margin for error. The wandering spider does not chase people, but it does not avoid them either. Its survival strategy is to occupy the same low, shaded layers humans move through without looking. Unlike snakes or large mammals, it does not announce itself with sound or bulk. It is carried unknowingly, worn, transported across thresholds from forest to house, field to floor. The moment of danger arrives not in the jungle, but in the act of dressing, lifting, or cleaning. Tasks stripped of vigilance by repetition. There is a deeper irony here. Humans fear predators that hunt us. The wandering spider is dangerous precisely because it does not. It intersects with us accidentally, as a byproduct of overlapping needs for shelter and warmth. In doing so, it exploits a cognitive blind spot. We scan for threats in front of us, not inside what we put on. We think of danger as external, not something folded into our routines. Ecologically, the spider is a regulator, keeping insect populations in check across vast areas. Its wandering behavior spreads predation pressure evenly, preventing any one patch from becoming depleted. This mobility also makes it resilient to habitat disturbance. Clear a field, and it moves. Stack lumber, and it colonizes the gaps. Human expansion does not eliminate it, it redistributes it. The close punch is not about fear of spiders, It is about misattribution. People imagine the bite as an attack, something sought out by a hostile animal. In reality, it is a collision between biology and habit. You did not hunt it. You did not provoke it. You wore it, carried it, compressed it into a corner where defense was the only option left. In the end, the Brazilian wandering spider teaches a specific lesson about risk in tropical environments. The most dangerous encounters are not dramatic. They are intimate and ordinary, embedded in daily actions. The bite is fast. The body's reaction is the switch, and the outcome depends less on the animal than on how quickly the human recognizes that the real emergency begins after the fangs are gone. The forest floor is not chaos. It is choreography. Every fallen branch, every root flare, every compressed tunnel through leaf litter marks a route that something uses repeatedly. In the lowland rainforest, movement concentrates along these narrow corridors because energy is expensive and resistance matters. Animals follow paths of least friction, even when those paths are invisible to human eyes. This is where the bushmaster waits, not coiled in open display, not roaming, not searching. It chooses a line of traffic and becomes part of the ground. The bushmaster's camouflage is not just coloration, it is placement. Its pattern breaks into the same mottled browns and decaying yellows as the leaf litter it rests on, but that alone would not be enough. What completes the disguise is stillness aligned with expectation. The snake does not lie randomly. It positions its body along the grain of the forest floor, parallel to roots and fallen sticks, aligned with the way shadows fall through the canopy. From above, it reads as debris. From the side, it reads as absence. Even the head disappears, angled slightly upward, resting at the height where a passing mammal's limb or chest will cross. Ambush venom works best when surprise is complete. The bushmaster is not interested in pursuit or prolonged conflict. It is a large pit viper, built for patience rather than speed over distance. Its strike range is measured and conservative, optimized for a single explosive motion rather than repeated attempts. Heat-sensing pits map warm bodies moving through the corridor, registering contrast rather than detail. The snake does not need to identify you. It needs to know something is there at the correct distance, in the correct direction. When the strike comes, it is short and decisive. There is no dramatic rearing, no prolonged display. The head moves, the fangs deploy, venom is delivered, and the snake recoils instantly. This is not hesitation. It is strategy. Remaining attached increases risk, especially against large animals that can retaliate. The bushmaster evolved alongside prey that can kick, bite, or trample. Its solution is to strike once and let chemistry do the work. This is where human misunderstanding begins. People expect venom to announce itself theatrically, to melt tissue instantly, to incapacitate in seconds, to create visible catastrophe. Bushmaster venom does not need any of that. It is a complex mix designed to disrupt blood clotting, damage tissue locally, and induce systemic effects that unfold over time. Pain may be present, but it is not always overwhelming at first. The bite may not bleed dramatically. The body feels intact, and that is the most dangerous phase. The switch is not biological alone. It is cognitive. Panic turns movement chaotic. People jerk away, stumble, grab at nearby bark or vines, increasing heart rate and circulation at exactly the wrong moment. Venom spreads faster when muscles pump and blood pressure rises. Decisions compound damage long before chemistry peaks. Delayed response is common because the absence of immediate collapse feels reassuring. People convince themselves the bite was dry, the snake small, the danger exaggerated. Time slips. Then the myths arrive. Tourniquets, cutting, sucking. Folk remedies that promise control but deliver harm. Tight bindings worsen tissue damage by starving already stressed cells of oxygen. Cutting increases bleeding and infection risk without removing meaningful venom. Oral suction removes nothing of consequence while creating new wounds. Each incorrect action buys the venom more time to do what it was designed to do: move. Bushmaster venom does not liquefy flesh in fantasy ways, but it does injure tissue methodically. Local swelling increases pressure within muscle compartments, reducing blood flow and worsening necrosis at the bite site. Blood clotting pathways are disrupted, creating a dangerous contradiction. Bleeding where it should stop, clotting where it should not. Systemic shock is a risk not because the venom is magical, but because the body's regulatory systems are being pulled in opposing directions at once. Blood pressure can fall. Organs receive less oxygen. Nausea, weakness, and dizziness follow, not as spectacle, but as consequence. In the forest, distance magnifies every mistake. Trails are rarely straight lines. They snake around flooded sections, fallen trees, and steep banks. People step over logs without checking the far side, place hands on bark for balance, or shortcut through undergrowth where paths narrow and visibility collapses. These are precisely the ambush corridors the Bushmaster favors. Low attention is not stupidity. It is fatigue. Long days in heat drain vigilance. Repetition dulls scanning behavior. Familiar trails feel safe until they are not. The Bushmaster's ecology explains its restraint. As an apex ambush predator, it cannot afford frequent strikes. Venom production is metabolically expensive. Missing or wasting venom carries a cost. This is why it waits, why it chooses placement carefully, and why it withdraws after contact. In its evolutionary history, prey that escaped did not survive long. The snake did not need to follow. It only needed to wait. Humans disrupt this equation by moving away from help. Instead of staying still, slowing circulation, and organizing evacuation, panic encourages distance, trying to walk out, to finish the task, to reach a familiar place. Each step spreads venom. Each minute without antivenom allows tissue damage to deepen and systemic effects to entrench. The snake has already done its part. From this point on, outcome depends on decisions. There is a quiet cruelty in how ambush venom operates. It does not announce urgency in ways people are trained to respect. There is no countdown timer, no cinematic collapse. There is just a window, and it closes invisibly. Antivenom works best when given early, before venom binds irreversibly to tissue targets. Delay turns a controllable envenomation into a prolonged medical crisis. Survival becomes harder, not because the venom changes, but because time was squandered. Understanding this reframes fear. The Bushmaster is not a monster waiting to punish mistakes. It is an organism perfectly adapted to its niche, occupying a role that stabilizes prey populations and shapes movement patterns across the forest floor. Humans are injured not because the snake seeks conflict, but because they enter the same corridors without reading them. The forest does not protect the inattentive. The final lesson is not about snakes. It is about tempo. Ambush venom wins when you waste time, arguing with yourself about severity, performing rituals instead of actions, moving when you should be still. In the Amazon, drama is optional. Consequences are not. Shallow water feels like a pause in the river's danger, a place where depth gives way to control and the current loosens its grip. The bank is close, sunlight reaches the bottom, and the surface lies calm enough to show your own reflection, broken by ripples. This is where people stop scanning, stop reading the water, stop thinking like prey. Beneath that thin illusion of safety, the stingray lies buried, invisible by design, its body pressed flat against the sediment like a living shadow. Its outline dissolves into sand and silt, eyes and spiracles barely raised, skin patterned to erase contrast. It is not hiding from you as much as it is hiding from everything. Predators above, currents that could flip it, and the energy cost of constant motion. Stillness is survival here, and the river rewards animals that disappear into its textures. The ray does not attack. It reacts. When a foot presses down where there should have been open water, the pressure spike is instant and overwhelming. Rays evolved to read pressure changes through their lateral line system and electroreceptors, sensing the faint bioelectric fields of prey and the turbulence of passing bodies. A sudden vertical load pins the animal against the substrate, compressing its pectoral disc and cutting off the escape routes it relies on. There is no room to glide forward or roll away. In that moment, the tail becomes the only direction left. Muscles coil along the ray's spine and release in a whip-like arc, faster than a human reflex can register, driving the serrated barb upward and backward toward the source of the pressure. The motion is not aimed. It is a mechanical reflex shaped by millions of years of encounters with crushing jaws and trampling hooves. The barb does not seek flesh. Flesh simply happens to be where the force resolves. The puncture is clean in entry and catastrophic in consequence. Stingray barbs are not smooth needles. They are flattened, jagged spines with backward-facing serrations designed to tear on withdrawal. Along the groove of the spine runs venomous tissue that releases a cocktail of proteins, causing intense pain, localized tissue damage, and vascular effects. But the venom is not the real danger. The river is. As the barb punches through skin, it carries with it a plug of the environment. Sand grains, plant fibers, fragments of decaying leaves, bacteria adapted to warm, oxygen-poor water. These materials are driven deep into muscle and connective tissue, beyond the reach of surface rinsing. The wound closes around them almost immediately as swelling begins, turning the puncture into a sealed pocket of contamination. This is where the injury switches from a moment of pain into a cascading problem. Swelling is not just an inflammatory response, it is a mechanical trap. As tissues balloon, they clamp down on embedded debris, making thorough cleaning progressively harder with every passing minute. Movement compounds the damage. Each step flexes muscle around the wound, grinding contaminants deeper and widening micro-tears along fascial planes. Blood and lymph flow increase with activity, distributing venom and bacteria farther from the entry point. What began as a single puncture becomes a spreading zone of tissue stress, heat, and pressure. The river has not finished yet. It has merely been invited inside. The first sensation dominates everything else. Stingray pain is not sharp and brief like a cut, but deep, radiating and relentless, driven by venom that activates pain receptors and disrupts local blood flow. People often describe it as burning from the inside outward, a pain that does not fade with distraction. This intensity creates its own trap. When pain overwhelms the brain, judgment narrows. Fine motor skills deteriorate. People fixate on escape rather than assessment, limping toward shore or a boat with tunnel vision, convinced that distance alone equals safety. In doing so, they miss the critical window for proper wound management, when irrigation could still flush contaminants before swelling seals them in. The myth takes hold here, passed along in beach talk and half-remembered advice. Pull it out. It's just a spine. It only hurts. The barb is often gone already, snapped off or withdrawn by the ray's movement, leaving behind the illusion of a minor injury. When fragments remain, improper removal can shred tissue further as serrations catch and tear, enlarging the wound and embedding debris even more deeply. Delay is just as dangerous. Pain can mask the seriousness of contamination, and because the injury may not bleed heavily at first, people underestimate what has entered the body. In warm, freshwater and estuarine systems, bacteria thrive that can cause aggressive infections once sealed into oxygen-poor tissue. The wound may look small. The problem it contains is not. As minutes turn into hours, the real consequence chain unfolds. Pain alters gait, forcing compensatory movements that strain joints and muscles already taxed by water resistance. Limping increases energy expenditure at a time when the body is diverting resources to inflammation and stress response. Fatigue sets in faster, especially in hot, humid environments where thermoregulation is already challenged. Sweating and dehydration thicken the blood, slowing circulation and immune response. Each misstep near the water's edge, slippery mud, uneven stones, submerged roots, becomes more likely as coordination degrades. The river does not need to strike again. It simply waits while exhaustion and distraction do the work. Ecologically, the stingray occupies a role that explains this entire interaction. Rays patrol shallow flats and river margins to feed on buried invertebrates, using electroreception to detect the faint signals of clams, worms, and crustaceans hidden beneath the substrate. Their flattened bodies and burying behavior reduce drag and exposure, conserving energy in environments where food is patchy and predators are numerous. The defensive barb exists because these same shallow zones are hunting grounds for larger fish, crocodilians, and terrestrial animals that wade or drink. The ray's survival strategy is not aggression, but last resort defense, a mechanical answer to being pinned. Humans enter this equation only by accident, stepping into a system already optimized for ambush and avoidance. There is a bitter irony in how often these injuries occur where visibility is highest. Clear, knee-deep water feels readable, but light refraction and surface glare can erase subtle contrasts on the bottom. A ray buried under a thin layer of sand is functionally invisible until disturbed. The shallows also encourage complacency. People slow down, spread out, and stop signaling to each other, assuming that danger belongs to depth. In reality, depth disperses risk. Shallow water concentrates it, compressing animals, humans, and movement into the same narrow band where mistakes overlap. The river finishes the job not with violence, but with time. Infections develop quietly, swelling increases, and pain persists or worsens, forcing further rest and delaying evacuation or medical care. In remote systems, hours can stretch into days before treatment, and what might have been managed with early cleaning and antibiotics becomes a systemic problem. Fever, spreading redness, and tissue breakdown follow, each stage harder to reverse than the last. The original puncture fades in memory, replaced by the broader struggle to recover from something that never looked dangerous in the first place. Standing at the edge of shallow water, it is tempting to believe that danger announces itself, that threats are large, obvious, and active. Stingrays contradict that belief by existing as part of the background, by surviving through stillness and reaction rather than pursuit. Their barbs are not weapons of conquest, but punctuation marks in an encounter that humans initiate without meaning to. The lesson is not fear of the animal, but respect for the environment that shaped it. Shallow water is not a margin of safety. It is a convergence zone where attention matters most. The moment people stop reading the river is the moment it writes itself into their bodies, one unnoticed step at a time.